In last lecture, students, I taught you inverse of a matrix. What is inverse of a matrix? I gave you the definition. And in that definition, we saw that if a square matrix is a non-singular matrix, I repeat, if a square matrix is a non-singular matrix, then only the inverse of the matrix will exist. Suppose you have a matrix A, and this matrix A has its determinant some number which is not zero. Its determinant is not equal to zero. Then you will say A inverse exists. You will say A inverse exists. A inverse exists. That is, matrix A has an inverse. Suppose there is a matrix B and you found the determinant of B and you got it equal to zero. So what you say? You say B is a singular matrix. A is non-singular, B is singular. And what you will say? You will say B inverse does not exist. It does not exist. What does that mean? It means the matrix B will not have an inverse. It will not have an inverse. Now listen, students, those matrices which have an inverse, those matrices which have an inverse, we say they are invertible. Like matrix A has an inverse. See, matrix A has an inverse. Its inverse exists because it is a non-singular matrix. So you will say A is an invertible matrix. You will say A is an invertible matrix, whereas B is non-invertible. That is, you cannot have the inverse of matrix B. So now here I have a question on the screen. You see a question in that you have three matrices, and see what does the question say. The question says, find which of the following matrix is invertible. So what you will do, you will simply have to get their determinant. So I start with my solution. I write here the first one as let A equals to 1 2 5 7. I write the name of this matrix as A. So A is 1 2 5 7. Now I find the determinant of A. Determinant of A is 1 2 5 7, and this is determinant sign. Okay, for matrix you do this, and for determinant you do this. Okay, so here now you find the determinant. You know the determinant. How to find determinant? It is 1 multiplied to 7 minus 2 multiplied to 5, 5 multiplied to 2. Okay, so here I get 1 into 7 minus 5 into 2. That is 7 minus 10, that is minus 3. So what is determinant of A? Determinant of A equals to negative 3. I got determinant of A equals to negative 3. What does it mean, students? It means that determinant of A is not equal to 0. It is not equal to 0. It means A is a non-singular matrix. So you write A is a non-singular matrix. It is a non-singular matrix. And remember, students, if A is a non-singular matrix, what you will say? You will say therefore A is an invertible matrix. A is an invertible matrix. That's the answer. So I solved the first one. The second one you can try. And the answer for the second one is you will get the determinant 0. So you will say that it is not an invertible matrix. It is not an invertible matrix. Let's go for the third one. In third one, once again, I take this matrix as A. So this matrix, I write let A be the matrix 1 2 3 2 4 5 and 2 4 6. What is next step? The next step is we will find the determinant of A. Determinant of A, you are writing the same numbers, but this time you are writing them between two parallel lines. Okay, so it's 1 2 3 2 4 5 and 2 4 6. Okay, now see here, what I do is I notice that in the third row I have 2 as a common factor. See, I have 2 as a common factor in the third row. So I can take 2 out. I'm using the properties of determinant. I can take 2 out from the third row. 2 is a common factor. So if I take 2 out, in the next step, I will get therefore determinant of A equals 2. I get the determinant of AC. 2 is out. This 2 is out from the third row. Remember, this 2 is out from the third row. So you get here 2 out. The first row is 1, 2, 3, no change. The second row is 2, 4, 5, no change. And the third row becomes 1, 2, 3. Okay, because you are taking 2 out, common factor out from this. So 2 becomes 1, 4 becomes 2, and 6 becomes 3. Now the next thing which I notice here is these two rows are identical rows. 1, 2, 3 and 1, 2, 3. R1 and R3 are identical. There is a property of determinant which says if in a determinant any two rows are identical, the value of the determinant is 0. The value of the determinant is 0. So here we will write determinant of A is 2 into 0. So determinant of A is 0, and therefore A is a non-singular matrix. It is a non-singular matrix. And it is a non-singular matrix. It means A inverse exists. You can find A inverse. And if A inverse exists, what you say? You say A is an invertible matrix. You say A is an invertible matrix. You write here, therefore, A is an invertible matrix. A is an invertible matrix. See, in this question, if I wanted, I could have gone without the properties. I saw that using the properties, it could be done faster. I opted for using the properties of determinant. But if you want, you can find the determinant of matrix A without the property. You can find the determinant by using the expansion. You know what is the expansion? The expansion would be you start writing 1 into 4 into 6 minus 4 into 5, 1 into 1 multiplied to 4c. You ignore this and this row and this column. So you have 4 into 6 minus 4 into 5. So you have 24 minus 20. You have 24 minus 20. Then you write negative of this element. So minus 2, and then you ignore this row and this column. So you have 12 minus 10. 2 into 6 minus 2 into 5. So you have 12 minus 10. Then you write plus 3 and ignore this and this. So you have 8 minus 8. That is 8 minus 8. Now see what you have here. 24 minus 20 is 4. 4 into 1 is 4. Then here you have minus 2 into 12 minus 10 is 2. And 3 into 0. 8 minus 8 is 0. So you get 4 minus 4 plus 0. 3 into 0 is 0, which is 0. See, you could have found the determinant even by expansion. But then I found it to be easier doing by properties of determinant. So I went by that method. Okay, so this is about the invertible matrix. The next I'm going to teach you adjoint of a matrix. I will teach you now adjoint of a matrix. What we are going to learn? We are going to learn about the adjoint of a matrix. See, students, Just before the adjoint of a matrix, I taught you inverse of a matrix. What I taught you? I taught you inverse of a matrix. I taught you inverse of a matrix. What you saw? We saw that inverse of a matrix is also a matrix. Please understand this. What did we see? We saw that inverse of a matrix is also a matrix. Similarly, adjoint of a matrix will also be a matrix. So suppose you have a matrix here. You want to find inverse of this matrix. This is, say, orange matrix. Okay, some matrix. Okay, so I call it as an orange matrix. It has some numbers. And I want to find the inverse of this matrix. The inverse of this matrix will also be a matrix. It is also a matrix. And it is one such matrix which you multiply with this matrix. You will get identity matrix. What you will get? You will get identity matrix. Unit matrix you will get 1, 0, 0, 1 if they are order 2. So you got the inverse of this matrix. Inverse of this matrix is also a matrix such that when you multiply, you get identity matrix. This was all the story about inverse of a matrix. We have adjoint of a matrix now. We have adjoint of a matrix. As inverse of a matrix is also a matrix, adjoint of a matrix is also a matrix. Yes, adjoint of a matrix is also a matrix. But before I teach you adjoint of a matrix, I will tell you the definition of adjoint of a matrix. See here. Consider a square matrix A. Consider a square matrix A. Then the adjoint of matrix A is denoted by ADJ A. Adjoint of matrix A is denoted by ADJ A. This is it. Like you wrote inverse of A, you wrote like this. So adjoint of A, you will write like this. Adjoint of matrix A is denoted by this way. Sometimes you may not write, you will find that the bracket is not written. It is okay, no worry. I prefer writing bracket. Sometimes you will find it. So this is adjoint of A. What is so special about adjoint of A? See, adjoint of A is a matrix such that A into adjoint A into adjoint A, that is, you are multiplying matrix A with its adjoint A into adjoint A will be equal to adjoint A into A, and that will be equal to students. Be careful, be very watchful. A into adjoint A equals to adjoint A into A, and that will be equal to, before I write this, tell me in inverse, let me recall, let me take you back to inverse. In inverse, you wrote A into A inverse equals to A inverse into A equals to, you wrote I. So here it will be I into determinant of A. That's the difference. Understand the difference. I deliberately took you to the inverse part. Why? Because there you have A into A inverse equals to A inverse into A equals to I. Here what you have, here also you have I, but with I you have the determinant of A multiplied. So what is, if somebody asks you what is adjoint of a matrix A, you will say adjoint of a matrix A is also a matrix such that A into adjoint A will be equal to adjoint A into A, and that will be equal to determinant of A into I. So we are going to now learn how to find adjoint of a matrix. So I will now teach you how to find adjoint of a square matrix. How to find adjoint of a square matrix. Let's begin. How to find adjoint of a square matrix. See, before we find adjoint of a square matrix, we will have to find, before finding adjoint of a matrix A, before finding, say some matrix A is there, okay, before finding adjoint of a square matrix A, we will find the minors of elements of matrix A and cofactors of elements of matrix A. So here, student, I'm writing notes so that later when you study, you will understand. See how to find adjoint of a matrix A. How to find adjoint of a square matrix A. Suppose this is a question to you. How to find square adjoint of a square matrix A. So the answer you will write, before finding adjoint of a square matrix A, we will find minors of elements of matrix A and cofactors of elements of matrix A. What does it mean? See, student, let me have a square matrix here. See, consider matrix A as follows. I write A here and I write it 3 by 3 matrix. See, A11, A12, A13, A21, A22, A23, A31, A32, A33. So we have this matrix which has got 9 elements, and I want to find the adjoint of this matrix. I want to find adjoint of matrix A. Remember, as earlier we defined, adjoint of this matrix A will also be a matrix. Remember, that is also a matrix. It will also have 9 elements. But remember, students, that this matrix you will get only when you will find minors of elements of matrix A. That is, to get the adjoint of matrix A, first you will have to find minors of all these elements. Yes, minors of all these elements. What are minors? I will tell you. Don't worry. Just listen, keep listening. You'll have to find minors of these elements. And you will have to find cofactor of these elements. Yes, you will have to find cofactors of these elements. Minors and cofactors. So it means we will have 9 minors and 9 cofactors. Once I have got the cofactors, then I'll be able to get the adjoint matrix. It is only then I'll be able to get adjoint matrix. Okay, so I will now solve a problem in order to make you understand that. You may copy this. So here you can write there will be 9 minors and 9 cofactors associated with 9 elements of matrix A, which we have to determine, which we have to find before finding adjoint of A. Before finding adjoint of A. So here we have a question in which we have to find the adjoint of a matrix, and the matrix is this. It's a square matrix of order 3. The question goes as follows: find the adjoint of following matrix. We have to get the adjoint of this matrix. Okay, it's a 3 by 3 matrix. So as I told you that a 3 by 3 matrix will have 9 elements. So I would be getting the adjoint, but before that, I will have to find the minors of each element. So there will be total 9 minors, and I'll have to get the 9 cofactors. Okay. Listen, students, if I have an element, see, if I have the first element here, like see A11, the minor of A11, I will denote it by M11. The minor of A12, I will denote it by M12. Minor of A12, you will write it as M12. Minor of A13 is M13. Minor of A21 is M21. This is M22, and so on. Similarly, the cofactor of A11, we will write C11, and so on. Okay, so let's start solving this question. So here I write, first of all, I assume this matrix to be a matrix A. So I write here A, let A be this matrix. It is 1 minus 1, 2, minus 2, 3, 5, minus 2, 0, minus 1. So I go for M11. See, I'm going for M11. What is M11? M11 is minor of A11, which is this element. See, this is A11. This is A11 because it's in the first row and first column. So its minor will be M11. And see, how do I get M11? M11 is, learn this. To get M11, which is minor of this element, you will ignore this row and this column. See, when you do that, what you get? You get a determinant, which is 3, 5, 0, minus 1. See, you get this determinant. It is this determinant which is a minor. Minor, what is meaning of minor? Minor means small, lesser. So you got, see, this was actually 3 by 3, but you are now getting 2 by 2 determinant. So you are calling it as minor. I hope you understand the meaning. So you got the minor of 1. What is minor of 1? Minor of 1 will be 3, 5, 3, 5, 0, minus 1. You calculate. So this determinant is 3 into minus 1. That is minus 3 minus 0. So you get minus 3. This is M11. After M11, you go for M12. You go for M12. See, now for this. So M12, you will write, you will ignore this row and this column. You will get M12, first row and second column. So you get -2, 5 and -2, -1. You're getting -2, 5, -2, -1. You can use your fingers while solving this on your notebook. Okay, just to point those numbers, you can use your fingers. So here you have -2 into -1, 2, minus of -10. See, this into this is 2, this into this is -10. So 2 minus of -10, so you get 12. What do you get? You get 12 here. Then you have M13. M13 is minor of A13. This is A13. So what you will do? Yes, you will ignore this and this. So when you do that, you get the minor determinant, -2, 3, -2, 0. So you get 0 minus of -6, that is 6. Then after that, you get M21. Now you go for this. See, we have found the minor of this, this, this. Now we'll go for this, this, this. So here I have the minor of -2. So M21, what is M21? You will ignore this row and this column. The row in which the element lie. The row in which the element lie. The element lies in second row and the column in which it lies, the first column. So what you have? You will have here -1, 2, 0, -1. See, you have -1, 2, 0, -1. This minor you get and you calculate its value. It is -1 into -1 is 1 minus 0. 2 into 0 is 0. So you get 1. Then you have M22. M22 is, you ignore this row and this column. What do you get? You get 1, 2, -2, -1. 1, 2, -2, -1. So here you have -1 minus of minus 4. See, minus 1 minus of minus 4, that is negative 1 plus 4, that is 3. Then you have m23. m23 is, you will ignore this and this. What do you get? You get 1, negative 1, negative 2, 0. That is 0 minus of 2, that is minus 2. 0 minus 2. After this, you will get m. After m23, you get now after m23, you go for m31. So see, m31, you will have determinant. You ignore this and this, 3, 1. So you have negative 1, 2, 3, 5. Negative 1, 2, 3, and 5, which is negative 5 minus 6, which is minus 11. Minus 11. Then you have m32. m32 will be, ignore this row and this column. So you have 1, 2, 1, 2, minus 1, 5. 1, 2, minus 2, 5. So you ignore this and this. So 1, 2, minus 2, 5. Minus 2 and 5. So here you have 5 minus of minus 4, that is 9. And then you go for m33, which is, you ignore this row and this column. So you get 1 minus 1, minus 2, 3, 1 minus 1, minus 2 and 3. So this is 3 minus 2, which is 1. So see students, we got all the 9 minors. We have found all the 9 minors. 4, 5, 6, 7, 8, and 9. Now, once we get the minors, the next one is we are going for cofactors. See, I will write here cofactors. The formula, see, there is a formula. The formula for calculating the cofactor of Aij. What do you mean by Aij? I mean the element in the ith row and jth column. Element in the ith row and jth column. See, ij, like A11, A12, that is what I mean, Aij. In general, we write Aij. So there is a formula for calculating the cofactor of Aij. And what is that formula? The formula for calculating cofactor of Aij is Cij. See, if the element is Aij, its cofactor is Cij. Like if the element is A11, its cofactor will be C11. If the element is A12, the cofactor will be C12. If the element is A31, the cofactor will be C31. Likewise, if you have the element as Aij, its cofactor will be Cij. And what is the formula? The formula is minus 1 raised to I plus j, minus 1 raised to I plus j into Mij into Mij. That means if I have, see here, so now I apply the formula. So see here, C11, what will be C11? It will be it will be minus 1 raised to 1 plus 1, because see, C11, minus 1 raised to 1 plus 1 into M11, into M11. What will be C12? It will be minus 1 raised to 1 plus 2 into M12. Okay, see here. What is minus 1 raised to? This is 1 plus 1, that is 2. You have 1 plus 1. Here you have 1 plus 1, that is 2. So minus 1 raised to 2 is 1. So you get equal to M11. What is minus 1 raised to 3? What is minus 1 raised to 3? It is minus 1 into minus 1 into minus 1, which is again minus 1. If you have the negative power of negative 1, you get negative number. Negative 1 you get. So this is negative 1. See here you have negative 1. You have your minus 1 raised to 3, which is negative 1 into M12. That is minus M12. That is minus M12. So here you have equal to minus M12. Then C13, C11, C12, C13. What will be C13? Cofactor of element A13. It will be minus 1 raised to 1 plus 3 M13. That is, now see, minus 1 raised to 4. You have minus 1 raised to 4, which is minus 1 multiplied to minus 1 multiplied to minus 1 multiplied to minus 1. 4 is an even number. So I understand if it is an even number, see, I'm going to get the pairs of minus 1. Minus 1 into minus 1 is plus 1. Then again here plus 1. So I get 1 into 1, 1. So if I have negative 1 power even number, I will get plus 1. If I have negative 1 power odd number, I will get minus 1. This I must understand. So here I have M13. So now look at this. I followed, look at this. I followed here that if the sum of these numbers is even, then the cofactor and the minor are equal. See, C11 is M11. C11 is M11. C13, look at this. What is 1 plus 3? 4. This is even. 1 plus 1 is also even. So C11 and M11, they are same. C13 is equal to M13. They are equal. They are equal. Whereas I noticed if I have the sum of these numbers odd, then C12 is minus of M12, negative. It is negative. It is negative. So C12 is minus M12. C12 is minus M12. Then C13. Now see here. C21. Now I go for C21. I go for C21. C21. What is 2 plus 1? 3. So it will be minus M21. Minus M21. You can write directly now. Okay. In beginning, you give the formula, the detail for 2 or 3, then you can write directly. No worries. C21 is minus M21. Okay, I need to write the values, so I will. I have not written the values so far because I was more into teaching you the concept. I will write all the values together at last. Now see, C21 is done. Now C22 will be M22. Why? Because 2 plus 2 is 4. So it is going to be same as M22. C23. What is 2 plus 3? 5. So minus M23. Then C31. After 2, 3, it is 3, 1. It is M31 because 3 plus 1 is 4. So C31 will be same as minor M31. Then C32. C31, C32. The cofactor 32 will be negative of minor 32 because 3 plus 2 is 5. 5 is odd. So if it is odd, then put a negative sign. C33. 3 plus 3 is 6. That is even. So it is same as M33. Now I will write all the values. See, We have already calculated those values. M11. What is M11? M11 is -3. So write -3. Now see here, you have minus of M12. What is M12? M12 is 12. See, you have M12 as 12. So here it will become -12. M13. What is M13? M13 is 6. So this will also be 6. Now you have negative of M21. What is M21? M21 is 1. So this will be -1. M22. What is M22? It is 3. So this will be 3. Then M23 is -2. So negative of -2. So 2. Then C31. C31 is -11. So it will remain -11. Now C32 is minus M32. What is M32? 9. So it will become -9. And then C33. M33 is 1. So here you will get 1. You got all the 9 cofactors. What do you got? You got all the 9 cofactors. Students, just one more step and you have the adjoint of the matrix. See what I had said, to get the adjoint of a matrix, you have to get the minor of all the elements and cofactor of all the elements. Now one more step and you are done with the adjoint. See, I will now write the matrix of cofactors. The matrix of cofactors is given as, see, you will write the matrix of cofactors. What is the matrix of cofactors? All the 9 elements that all the 9 cofactors you got. All the 9 cofactors you got, you make a matrix of those 9 cofactors. So begin. C11, -3, -3, then -12, C12, -12, then 6, then C21, -1, then 3, then 2, then -11, then -9 and 1. What is this? This is the minor of, this is the matrix of cofactors. What you wrote the matrix of cofactors. Now you will write adjoint. Therefore, adjoint of A is equal to, students, write the transpose of this matrix. Write the transpose of matrix of cofactors. So when you write the transpose, what you do? You interchange rows with columns. So first row is -2, -12, 6. So -2. The first row is -3, -12, 6. So -3, -12, 6. The second row is -1, 3, 2. So -1, 3, 2. You make it second column. And the third row becomes third column. -11, -9, and 1. That is it. You got the adjoint of the matrix A.